All right, so once again, just a quick reminder that if you complete an outdoor activity over February break, you can earn 5 extra credit points. These are just some of the things that you can do to get outside and enjoy your winter break. Get out of the indoors and into the outside and have yourself a good time. So 5 points of extra credit. Send me an inbox message and maybe a little description. Would like to hear what you're going to do or what you did over break. All right, so today we talk about factoring the difference of two squares. It's a Thursday right before break. This is not going to be stressful, not going to be difficult. One of our easier lessons in the whole polynomial scheme of things, okay? So this one should be pretty manageable by the end. First of all, let's talk about what it means to be the difference of two squares, which, by the way, is typically talked about as dots. So if you have a teacher say dots, what they're saying is the difference of two squares. It's an acronym for that process. Okay, so what does this mean? Whoops, now I got to go back to my pointer here. What does this mean? Oh boy, come on, Clear Touch, work with me here. It means when two binomials only differ by their sign. So we're going to have two terms, two of those, and the only difference is an adding and subtracting sign. And we'll get to more of that in a second. But first we have to understand what the difference of perfect squares are. It says the difference of two squares, that's exactly what it means. Two squares that exist somewhere out there in space. Now, in order to be a square, we know that it has to have the same length on each side. So if one's 7, then they're all 7, right? So I have labeled two sides 7 because to find the area of this, it would be 49. And so we could write the area as the length times the width, and that would give us 49. Just multiplying two sides gets you the area. Now, what if it's just y? We don't know the length, but we know all the sides are y. Well, multiply the two sides to create the area. Remember to add exponents, so that would be y squared. Now, if you're asking or wondering why this isn't on your notes, I did this as like an additional help you to understand what's going on here. So if you want to write this down, go ahead. If you just want to sit back and internalize this, that's fine too, just to kind of get the picture in your head of what's going on. Next up, we have a square that has a side length of 4c. Just go with me here. It's going to make sense in a little bit. But if one side's 4c, then they're all 4c. And to find the area, we multiply a side times a side. So that would make 4 times 4, 16. And then c to the second power. So we can have just a number, just a letter, or a combination of number and letter. So that's a little bit more traditional to go in that direction. Now let's start with the actual area and see if we can come up with the two sides. So we have a square with an area of 36. And we want to think about what the length of each side is. Now it's got to be the same, right? So what would you multiply that's the same number to get 36? Hopefully you're thinking about 6 times 6, right? So all the sides are 36, but I just broke it up into 2 because a side times a side makes an area. Next up, s squared. So the 2 means that there are two s's because the area was formed by multiplying a side by a side. So s and s. And finally, 81x to the second power. So both a number and a variable together. Well, this would be 81 as a perfect square, meaning each side has the same number. How about 9 times 9, right? So 9 times 9 makes 81, and then x squared is an x with another x. So, all right, let's dive into this now. So write each as the product of binomials by looking at the graph on your calculator. We're not going to do that today. We're just going to do this the old-fashioned way with factoring, but we are going to make it a product of binomials. So what does that mean? That means that we're going to write this as two binomials. Now you have to think about each term as being the area of a square. So if we have a square with a side length of x squared, So draw a quick little square and see this as x squared. Well, this is really x times x, right? So the first term of each one of these binomials is x. Not so bad. Now let's take a look at the 9. The 9 is the area, and what number could we multiply to get back to 9? Just one number. Well, this side is 3, and so the other side would have to be 3, because 3 times 3 makes 9. So we have a 3 here and a 3 here. So it looks like we've created the same binomial, but the word difference means that the signs are different. So you go one positive, one negative, and that's it, folks. You're done. You have factored a perfect square binomial into two binomials. You've broken up in those squares into the two side lengths. All right, I hope that makes sense. I'm trying to give you a real life perspective of this because other than that, it's hard to kind of apply this. All right, let's go again. Let's try x squared minus 4. I'm not going to do the shapes this time. I'm just going to keep it simple here and just make two binomials. And again, break this up into two pieces, break this up into two pieces. The variable is usually the easiest. X squared, there's two x's, so go x and x. Excuse me. And then the 4, what one number multiplies the 4? And I say one number because the side of a square is always the same. So the side of a square could be 2, then they would all be 2. And then the difference, it's the key to the word here. Difference, they have a difference of sign. One positive, one negative. And there you have it. That's it. That's all you really have to do. But hopefully with doing the shapes, it gives you a better understanding of the whole process. All right. Last one, x squared minus 25. Again, this is going to be broken up into two binomials. So let's go x and x. Now, can anybody... So once we've done our double distributive move, let's go ahead and do the normal distributing. So I get x squared minus 5x and 5 times x and 5 times negative 5, a positive 5x and a negative 25. Usually when we multiply binomials, we get a trinomial. We get a 3-term polynomial. But the difference of two squares makes something happen, something unique that's a little bit different. And that is when we go to combine like terms, the negative 5x and the positive 5x cancel each other out. It makes 0x, and therefore we don't have to write it, and that is why when we multiply these two binomials, we get a binomial and not a trinomial. Okay? All right, so those are the definitions or the answers to these two questions. If you're watching the video, please pause and write those down. Now, let's take a look at these perfect squared binomials and factor them into two binomials. I'm going to do this one more time and let you try the next two. So again, just kind of get the setup down for what these are going to look like. And these are going to look like two binomials. 1, 2. So get two sets of parentheses down where they each have two pieces. So the x squared is the area of one square. So I break it up into the two side lengths. If I have two x's, I put one x in the first binomial, one x in the second. And then 100. What one number multiplies to 100? Hopefully you're not bad with your multiplication facts because that would make this pretty easy, and it would be 10 times 10. So they look the same until you put in the signs because one's positive and one is in fact negative. So hopefully you saw that the answer to this are the two binomials that would look almost the same, x and 8, x and 8, with one positive and one negative. Now come on over here, set yourself up for success. Go ahead, write two binomials, 1, 6, 1, 6 there. Now this one I wrote as a positive negative. It does not matter which one goes first. I could write this one as a negative, then positive. And there you have it. You have factored these binomials. So let's take a look at this in terms of a rule. The rule for what we've been doing is simply 2 break each term into two of the same pieces. All right. And another x for the other binomial. Now if it's a squared and there's two of them, 1a there, 1a there. So they look almost the same. They have the same pieces, but one is positive and one is negative. All right. So hopefully we're ready for the grand finale here, and I've got a couple of questions here that hopefully will challenge some of you that were looking for a challenge this morning. So let's take a look at when we have a number and a variable. Now we kind of prepared for this back at the beginning. Let's break this up into two binomials and think about the same piece here and here. Now, how did we get the 4x squared? How was that area coming together? What two sides would we have? Well, the 4 has got to be 2 times 2. Those numbers have to be the same. And x squared, just there's two x's. So 1x and 1x. Not so bad, right? Second piece. So it's got to be almost the same, right? So 9 could be broken up into 3 times 3. And then the y squared means there's two y's, one y there, one y there. And there you have it. Those would be the side lengths of that square. Now don't forget, still the same thing applies. One of these is positive and one of these is negative. Last one of the day, folks. So if you have any questions, please let me know, because after this, it's practice time. So it's going to look like two binomials. We're writing an equivalent expression. 81 would be, well, let's go 9 times 9, right? And don't divide these by 2. Just keep trying to multiply a number by the same number, and when you get to 81, that's when you know you've reached the right answer. So like for this one, 36. What times itself gives you 36? And start with like 4. 4 times 4, 16. Not enough. 5 times 5, 25. Not enough. 6 times 6, yes. So it's got to be the same number. Now, the b squared that's after that, again, there's just two b's, so one b there and another b there. Finally, finish it off. One negative, one positive, and you have just factored using the difference of two perfect